Rabbit, and today we'll be discussing measurement and matter. On measurement of matter, chemistry is a quantitative science. Quantitative means that the information present is based in quantities. To perform problems in chemistry, you must be able to measure the amount of matter that you have. There are three ways to measure matter. The first is by counting. An example of this is there are 130 songs in your music library. You can also determine the mass. An example of this is that a sample of gold has a mass of 2 grams. You can also determine the volume. An example of this is that milk is sold in gallons. Certain terms represent an amount, such as a pair meaning 2, a dozen meaning 12, and a gross meaning 144. For an example of this, apples can be measured by mass, weight, count, and volume. An example of count is that 1 dozen apples is equal to 12 apples. Mass, 1 dozen apples are equal to 2.0 kilograms apples. And for volume, 1 dozen apples is equal to 0.20 bushel apples.
Hi, this is Christopher Chou. I'll be going over the practice problems for section 10.1 on page 307. The question of this section is how can you convert among the count, mass, and volume of something? And knowing how the count, mass, and volume of an item relate to a common unit allows you to convert among these units. The book shows the steps for the first problem. First, identify the sequence of conversions needed to perform the calculation. Then, write the conversion factor to convert the number of apples to dozens of apples. From there, write the conversion factor to convert from dozens of apples to mass of apples. Then, multiply the number of apples by these two conversion factors to get the answer in kilograms. The answer is 15 kilograms of apples. The first question is if 0.2 bushel is 1 dozen apples and a dozen apples has a mass of 2 kilograms, what is the mass of 0.5 bushel of apples? Using dimensional analysis, I was able to show that the conversion factor is 12 apples to 0.2 bushel. If we had 0.5 bushel, using the conversion factor of 12 apples to 0.2 bushel, and knowing that 2 kilograms is 12 apples, I was able to use cross-canceling to show that 0.5 bushel equals 5 kilograms. Once again, this is Christopher Chou going over section 10.1, and these practice problems can be found on page 307 in the textbook.
I'm Dante, Arcese, and I'm going to talk to you about the mole. A mole of a substance is 6.02 times 10 to the 23rd representative particles. The number 6.02 times 10 to the 23rd is called Avogadro's number. The mole allows for chemists to count the representative particles. Example problem. How many moles of magnesium is 1.25 times 10 to the 23rd atoms of magnesium? First step would be to take 1.25 times 10 to the 23rd atoms of magnesium, multiply it by 1 mole of magnesium, and divide by 6.02 times 10 to the 23rd atoms of magnesium. When you do the math, you find out there are 0.208 moles of magnesium in 1.25 times 10 to the 23rd atoms of magnesium.
I'm Jake Belham, and I'm going to be talking about the number of atoms in 1 mole of a compound. Okay, so first we need to know how to add up the number of atoms in a molecule. So we have 1 atom of carbon, but you wouldn't write this. And then you have 2 atoms of oxygen. So add these up and you have 3 atoms in 1 molecule of CO2. You also need to know Avogadro's number. Avogadro's number is 6.02 times 10 to the 23rd. Okay, now let's try a practice problem. How many atoms are in 2.12 moles of propane? So first for this problem, I'm going to write down the given, which is 2.12 moles of propane. Next, we're going to write down the conversion factor for moles to molecules. That's going to be 6.02 times 10 to the 23rd of propane over 1 mole of propane. Then we're going to write down the conversion factor for molecules to atoms. So that's going to be 11 atoms over 1 molecule of propane. Alright, so the moles should cancel out, and the molecules should cancel out. And after multiplying these three numbers together, you should get 1.40 times 10 to the 25th atoms. And that's how many atoms are in 1 mole of propane.
Hi, I'm Sydney Daniels, and I will be explaining the basic terms and concepts of molar mass. The mass unit mole is a relative term, meaning it is different for each element and compound. It is based on the amount of molecules in the substance. 1 mole contains 6.02 times 10 to the 23rd molecules, which in the last section was defined as Avogadro's number. This varies between elements because of the different amount of protons, neutrons, and electrons each element has. When calculating the molar mass for an individual element, look for the atomic mass and add the label grams. For example, the atomic mass of aluminum is 26.982 AMU, or atomic mass unit. We change the label to grams, and we find that 1 mole of aluminum is 26.982 grams. To calculate the molar mass for a compound, you must first know the formula and calculate the molar mass for each individual element in the compound. For example, we have calcium chloride, which is CaCl2. From looking at the formula, we know that there is 1 calcium and 2 chlorines. Then we look at the periodic table and see that the mass of calcium is 40.08 and the mass of chlorine is 35.45. Since there are 2 atoms of chlorine and only 1 of calcium, we multiply the mass of chlorine times 2, which is 70.90, and add the mass of calcium, which is 40.08, and we find that the molar mass of calcium chloride is a total of 110.98 grams.
My name is Megan Berube, and I'm going to show you how to find the molar mass of a compound. I'm going to use hydrogen peroxide, or H2O2, as an example. First, write down the elements that make up the compound, which in this case are hydrogen and oxygen. Then find the molar masses of each element from the periodic table. For hydrogen, the molar mass is 1.01 grams, and for oxygen, it is 16.00 grams. You multiply the molar mass of each atom by how many atoms are in the compound. There are 2 atoms of hydrogen and 2 atoms of oxygen. Multiply those and you get 2.02 grams of hydrogen plus 32.00 grams of oxygen. Add these 2 molar masses together and you get the molar mass of the compound hydrogen peroxide, which is 34.02 grams.